Hi everyone, welcome to the fourth lesson for topic 3.1 Bivariate data analysis. So this is also the last lesson which we will be discussing categorical data. So after the coming CNY holiday, which means starting from next week, then we will be looking at numerical data. Okay, so today's lesson is pretty short because there's no much of so-called like practical part which you need to draw the graph and so on. So it's basically theory, and we will be looking the same thing when we move into numerical data as well. Okay, and I doesn't want to actually start numerical, then after that, after you have a break, then after that you continue, then you might forget. So yeah, that's why we try to talk about this first. I think this is helpful for you to have a better understanding on this whole topic as well. Okay, so for today's lesson, we are going to talk about association and causation. Okay, so I hope that now you are quite familiar with this term already. So association is a word that we use to describe the relationship between two variables. Okay, so when we carry out bivariate data analysis, which means we are interested to know whether there is an association that exists between these two variables or not. Okay, so the two main objective for the day is that we need to recognize that when there is an association, it doesn't mean that there is a causal relationship. Okay, so we'll be looking at what is that meant by causation or causal relationship. Then the second thing is, if let's say it's non-causal, then what is the explanation? So we'll be looking at few explanation, including things like what is that meant by coincidence, the confounding variable, then also what is that meant by common response. Okay, then we are going to try to communicate the explanation in a much more concise manner. Okay, so basically that's the idea for today's lesson. So let's start with the first one. All right, let's look at this new term here, causation, causality, or sometimes it can be called as the causal relationship as well. So by looking at these words, right, all these words actually comes from the root words of cause, right? So that's why by looking at the words, we know that causation is basically the relationship between the cause and also the effect. So which means when we say A causes B to happen, so or like when A happen, then B will happen. So this is like a cause and effect relationship. So remember that we only use this term when the explanatory variable absolutely and also solely affect the outcome of the response variable. So which means that there's no other variable that can actually affect the outcome. It's only the EV and also the RV. Okay, so let me give you an example. So if let's say we are going to make a Osmat t-shirt, so we specify that for the boys it's like a blue color shirt, then for girls it's like pink color shirt. So that's why you can see this is like just a simple causal relationship, right? So that's why when you are a boy, then you should wear a blue one, and if let's say you are a girl, then you will wear a pink one. So you can see that's like a very huge difference there. I mean, whenever when you try to look at the graph thing, right? So if let's say you have 20 girls, then of course you will have 20 pink color shirt. Then if let's say you have 10 boys, then it will be 10 blue color shirts. So that's the idea for like causality. Okay, so now let's try to look at the relationship that we learned previously, which we mentioned about association. So versus the causation that we look at today. Okay, so I hope that you still remember association is basically a general term for us to describe whether there is a relationship between two variables or not. So we talk about x and y. So yeah, it's like the explanatory variable and also the response variable. So can a change in response variable explain a difference in the change of response variable or not? Okay, but then we must remember that an association does not imply causation. So basically meaning that simply knowing that two variables are associated or correlated, right, it is not sufficient for us to conclude that the two variable has a cause and relationship. Okay, so later I'll try to give you examples on this. So which means in another words, right, when we say that the two variables are correlated, so which means even that x can use to explain the difference in y, it does not necessarily mean that a change in one actually causes a change in another. So this is like the words. It's not that we never use, but then in majority of the case, which we do not have a perfect association, then we wouldn't use the word cause here. So there might be a causal relationship, like what I said, but we cannot assume that the causal relationship actually exists purely based on the basis that there is an association. So which means by looking at the graph that we look at in the categorical data or numerical data, so we wouldn't actually say that there is an association, so that's why A caused B to happen. Okay, so let me give you a very simple example here. So normally we say that a person's height and weight have a high positive association, right? So which means that in a general case, we know that if let's say a person with a higher height, so which means when the height of a person increases, so what happens is that the weight will normally be increases as well. So this is like a very normal situation, right? Especially when we look at like a baby versus an adult, then in a journey where he growing up. So that's why when the height increases, then obviously the weight will be increases as well. But then can we actually say that a change of height cause a change in weight? Okay, so you see, right? That's the idea. So maybe when you reach a certain age, then you know that maybe you are not going to grow any more, any higher. Okay, but then the problem is that maybe you eat a lot of food, then maybe you can become, I mean, your weight can become higher. You get what I mean, right? So that's why we cannot actually compare these two variable in terms of like the cost actually cost the height. So we cannot say that when your height increases, then definitely your weight will increases. And we also cannot say that if you are lower in terms of height, then which means your weight will be decreases. Because that can be like external factors such as like what is the diet that you are going to take. So stuff like whether there's any health problem. So which means when you try to compare someone that doesn't have enough food to eat, and also someone who is having obesity, you get what I mean, right? Then after that, maybe the amount of exercise that someone did in like weekly and so on. So these are all the factors that can actually affect weight. So the height is not the only reason, is not the only cause that going to bring the effect of the weight. Okay, so I hope that you can get the idea. So this is some notes here that you might see in your exercise and so on. So when we talk about positive correlation, so actually we'll look at this word in a much more concise manner when we move into numerical data. So you will be looking at this term, so I think it's helpful when I just try to mention it here. So when we talk about positive correlation, so stuff like positive association, right? So which means that when X increases, then the Y increases as well. So which means, for example, when we say that weight and height has positive association, so which means when height increases, then the weight increases. So when we say, so it's the same thing when we say that when X decrease, then Y will decrease lah. So basically, like what happened to X, that's the same thing happened to Y. So for negative correlation is the opposite way. So which means that when X increases, then Y will decrease. Okay, so that's like the idea of it. Okay, so now we are going to look at some possible explanation that we can try to explain why is that an association observed there. Okay, because we know that for all for association, it doesn't imply causation, right? So what are some of the possible explanation that we can try to give in those situations? Alright, so this is a general possible explanation when there is a association. So please remember that if the question require you to make like any justification, or when you look at the question, it actually contributes like more marks, then you should realize that the justification or the reason that you try to give, it should be a much more specific one, but not just talk about the general idea that then you stop there. Okay, so this is like as in whole. Okay, so now, so these are some different cases where when we say that there's association. So the first one is like what I say, which is quite rare to happen, is like when the explanatory variable is actually causing the change in the response variable. Okay, so please remember that you only say this if, let's say, you have a perfect correlation or the reasoning is like very evident. So the stuff that can be decided by, I mean, for like what I said just now, so the color of shirt that you buy is based on the gender that you are. So that's why this is like a perfect correlation. So if you are girl, then what happened? If you are boy, then what happened? There's no other chances that other thing that can happen, right? So this is like a perfect correlation. Okay, then the second thing is called as the confounding or the lurking variable. Okay, so this is actually an additional variable rather than your explanatory variable and also the response variable. So this is an uncontrolled variable which the effect cannot be taken away from the uncontrolled. Okay, so which the effect cannot be taken away from the effect of the response variable. So what happened to the confounding and lurking variable is it will actually create a common response. So this common response is caused by you have this additional variable that is going to be associated with both explanatory variable and also response variable. Okay, so we will be looking at this with few example later, so don't worry about that. Then the last cases is just a purely coincidence. Okay, so let's try to look at this one. So this is a very interesting example. So you see, right? Actually, that's like when we try to do an investigation, we can actually find out that there is a positive correlation between the monthly sales of ice cream versus the monthly number of deaths due to drowning. Okay, so you see, by thinking of it, then you know that in terms of logical, it seems like incorrect. Am I right? So which means that I mean, how can you say that the monthly sales of the ice cream increase then the monthly number of deaths also increase? Okay, so why is that so? So the first thing is by looking at this, then logically you know that it is obviously incorrect to say that if let's say there's an increase in the monthly sales of ice cream, then this will cause the monthly number of deaths due to drowning to increase, right? So, or you say that the monthly sales of the ice cream decreased, so that's why the number of deaths due to drowning actually decreased. So, yeah, it's incorrect to say that, right? Okay, so but why is this association happen? So actually what happened here is that there is a confounding variable. Okay, so you can think of, is there any variable that actually associated to this both thing or not? So that's this thing which is temperature. So why is that so? Because of, when the temperature gets higher, so which means on a hot day, so if let's say the weather is hot, right, then which means that more ice cream will be sold. So if let's say the weather is hot, then more people will go swimming. Then when more people go to swimming, then of course the deaths due to drowning will be increases as well. So when you try to look at it like this, then A is quite logic, right? But we wouldn't say that the A causes the B, right? But this is an confounding variable, which is temperature, that causes that for the X variable and also Y variable is having a common response on it. So that's why in this case, the monthly sales of ice cream and the monthly number of deaths due to drowning have a common response to temperature. So which means it's because of temperature change. So that's why what happened to that is that when you have more ice cream sold, then which means there will be more deaths due to drowning as well. So it's the same thing as well. If let's say the weather is like a cold one, then less ice cream are sold, right? So and because of the weather is cold, then less people will go swimming. So that's why the deaths due to drowning is decreasing also. So by looking at this example, I hope that you can have an idea of the difference between when we say that there is an association, causation. So that's like totally different thing. Okay, so let's try to look at these three examples before we end this very short video. So there is a positive association between the number of televisions and the life expectancy of the world's nation. So do you think that having multiple television actually increases the life expectancy? Yeah, so we know that it doesn't, right? So we can just answer no. Okay, why is that so? Because by having these two variable having a association, it doesn't mean that that is a causation, right? So you can just write out this does not imply, oops, I'm sorry. This does not imply cause and effect relationship. Okay, then what do you think is the possible explanation to this association then? What do you think? Why is that so that the number of television? So yeah, because when we say that that is an association, it actually means that the change in number of television actually explain the difference in the change of the life expectancy, right? So if let's say we don't say that this caused this to happen, then why is this association happen? Okay, so we can look at it like this. So why is that so? Because there is a confounding area. So sorry, there is a confounding variable. So what is the possible confounding variable in this case? Yeah, maybe it's purely because of the society is keep I mean the society keeps on developing, right? So that's why the technology is actually keep on improving. So what happened is when everyone can afford to get a television, so which means the number of televisions that each family own is increasing. So which mean the economic status of of the country actually becomes better. So when they become better, then which mean in another words, so which mean the health services and the hospital services, everything will actually become better as well. And because of the technology is actually developing, and this is why the life expectancy of the worst nation is actually increasing as well. So this is like having a common response to like how the society is developing. It's not because of this happened then the other thing happened. So it's the same thing when we try to say that when the speed of the internet getting faster and faster, then the life expectancy of the worst nation also gets faster. Okay, it's not in that case, right? So it's just because of when we say that the Wi-Fi speed is getting faster, it's actually because of we have a better technology, then we are living in a better society now. So that's why it's because of that we are having a much more better health services compared to like our previous generation. So that's why the life expectancy is actually longer as well. So that's the idea. Okay, so number two. So when we say that there is a positive association exists between the amount of exercise and the risk getting cancer, so do we say that having more exercise actually prevent cancer? Okay, yeah, so we know that this might be one of the variable, right? So that's why we can say that is no. Okay, because we know that there can be a lot of other factors that actually affect someone whether they have cancer or not, right? So yeah, you can just write the same thing. I'm just going to write cause and effect relationship. Okay. So yeah, how are you going to explain this? So maybe you can just mention that there can be other variable, right? So there are other variable involved. So stuff like for example, I think for cancer, maybe one of the very important factors that we can say is like for example like the gene. Okay, so if you have like your previous generation is having a gene of cancer, okay, so stuff like that, then maybe it's because of your diet and so on. Okay, so amount of exercise is not the only factor that is going to cause whether you get a cancer or not. Okay, I think this is pretty obvious. Okay, then the third one. So a person observed in several occasions when he goes out from home, the weather is likely to be raining. So when you go out, then it's like raining. Okay, so do you think that is there a causal relationship between the person go out and the weather? So yeah, obviously, I think this one you'll agree with me that it's no, right? So we cannot say that when a person go out, it caused the weather to be raining. So that's why in this case, what do you think is the idea? Yeah, it's actually a pure coincidence. Okay, so this is like something that you can have. So yeah, for example, when we say right, when someone get into a job, then after that, the sales of the company actually getting better. So it can be because of the person's performance is very good, but it can also be when the people that coming in is the time when the company is trying to recruit more people because they are expanding their business. So that's why when this person come in, then the business of the company become better. So this is like a pure coincidence as well. So it's not because of this person coming in so that caused the sales of the company become better. Okay, so I hope that you can understand the whole idea. So basically I hope that you can see that having an association doesn't mean that there is a causation. So we wouldn't say that when A happened then B happened, and we wouldn't say that A causes B happen, except you really have a very valid reasoning with like the results that you can see in your analysis. Okay, so that's the idea. So just some reminder before we end this video. So remember to complete your homework. Then the other thing is, yeah, please make sure that you get your calculator ready before next week, because we are moving into numerical data after this. And then we are going to have a live class for the coming Tuesday, meaning next Tuesday. So yeah, make sure that you remember this and attend the live classes on time. All right, so that's it for today's session. Thank you.